Okay, here is our review video for chapter 8. So first up is the graphing. So we have this equation, y equals 2 over x plus 3 plus 1. So first thing, when you type this in your calculator, you are going to need parentheses. Do not forget those. So even before we put it in the calculator, though, we can figure out the asymptotes. So the horizontal asymptote is the number on the end. So horizontal is always a y, so y equals 1. The vertical asymptote, you take the denominator, you set it equal to 0, and you solve for x. So x equals -3 is the vertical asymptote. Back to the horizontal asymptote for a second. When we have the other kind of equation, and I'm just kind of picking some random numbers here, we look just at the first, basically the x's. We would take that fraction, 2x over x, and we would simplify it, and we would get 2. So like I said, that was a random example I picked. When you have x's on the top and bottom, it's different than the example we have on the top up here. So when there's a number added on the end and there's no x on top, that number is the horizontal asymptote. When there are x's top and bottom, you look just at the x's, you simplify the fraction, and that is the asymptote. Vertical asymptote is the same no matter what. You set the bottom equal to 0 and you solve. Alright, so now to graph it. My vertical asymptote means that there will be an asymptote there and horizontal. I'm not happy how that looks. Let's get it on the line. There is our horizontal asymptote. So now I'm going to make my table. I'm going to go from -6 to 6 all the way across the x-axis here. -4. All right. And then I'm going to put this in my calculator and look at the table. So remember to use parentheses like I put on there. And we've got 2 over x plus 3 in parentheses plus 1. Look at the table, and I've got 0.3, 0, -1, error. So this is another sign. This is our vertical asymptote. 3 to 1.7, 1.5, 1.4, 1.3. This actually rounds to 1.3 as well, so we can see that it's flattening off here. Our points are getting really close. And 1.2. Alright, so now let's graph those. So 6 is 0.3. So just a little bit above the line. 0, -1. And then we have our asymptote. So just this little curve here, it comes down and ends up going straight down. And then 2 is 3. -1 is 2. 1.7. 1.5. And then it gets really flat. I'm going to kind of jump out to 1.25. And because it's so flat, I'm just going to connect them here. So comes almost straight down, curves, and then flattens out nicely. So on both these curves, we're going to have arrows on both ends. All right, domain and range. All right, it's not letting me erase that a little bit. So the domain and range are the opposites of our asymptotes. So domain is our x's, and so it's all real numbers except -3. So x does not equal -3. It equals everything else. Y does not equal 1. Now our word problem. The YMCA is trying to organize a week-long summer camp for kids. The facility they want to use is going to cost the YMCA $15,000 for all lodging and food and $20,000 for transportation to and from the camp. Okay. Each participant is going to pay the same amount. Write a function that gives the average cost of the camp per participant, where x is the number of participants, number of campers. So let's find just the total cost in general. So it's $15,000 for the lodging and food plus $2,000 for transportation. So we've got $17,000. And now if each camper is going to pay the same amount, we just average it. We divide by the number of campers. So our equation is y equals 17,000 over x. So now we're going to do another graph here. So in your calculator, 17,000 divided by x. So we don't need any parentheses. Oop, not times x. All right, and as you can see from our graph, we have some big numbers here. So I'm just going to go down to my table to where it says 20, and so we're counting by 20s here. So we don't need to put every single number. Oh, hold on. All right, so for my first one, I got 850. Well, that does not fit on my graph, so I'm not going to do that one. For my second, for 40, I got 425. So about halfway here. So this is 425. I'm not going to write these all. I'm just going to kind of get us started here. 60 is 283. 80 is 212. And I'm just estimating. These aren't perfect. 100 is 170. 120 is 141. 140 is 121. 160 is 106. 180 is 94. And we can see it's flattening off quite a bit here. 200 is 85. I'm going to jump out to the end. 280 is 60. So then I'm going to connect these. So it comes not quite straight down, but it comes down pretty fast. And then kind of levels off near the end here. All right. So what lowers the average more? The number of participants changing from 40 to 60 or from 20 to 40 or 120 to 140. So 40 to 60, that is from here to here. So that is a difference of a couple hundred, almost a couple $100. If we subtract the two values at 40 and 60, we get $142 or yeah, dollars per student difference. The jump from 120 to 140, well, if we look at that little part of the line, that's not nearly as steep as this part of the line here. So the jump from 120 to 140 there was only about $20, whereas it got $142 cheaper before. So we save more money going from 40 to 60. And then using the table, when is the cost below 75? So just look for the first number less than 75 in your table. And it is 227 students. I would accept some rounding there. I mean, even like 230, or because we were counting by 20s, even 240 is the first one in the table that would be less than 75. So I am okay with rounding campers. All right, next page. Okay, simplify the expression. So we're going to zoom on in here. So to simplify this, we need to factor it. So what adds to the middle and multiplies to the end? So x plus 5, x minus 2, over x plus 8, x minus 3, times, and because we're multiplying, I'm just going to make a big fraction here, x minus 3, and then x plus 4, x minus 2. So then cross off the ones that are repeated top and bottom. The ones that are left become the simplified answer. X plus 8 and x plus 4. There we go. That is your final solution. Next one, solve. So this is a nice easy one with a whole number. So we are just going to cross multiply. Oop. Oh, come on. And the x plus 2 stays exactly the same. I guess we don't need parentheses. The 2 times x minus 3, we need to distribute the 2. Minus x, plus 6, plus 6. So these cancel, these cancel. We get 8 equals x. There we go. Next one. A little bit longer here. So this one, I'm going to use a method that I know my 6th hour, we talked about a little bit more. My 3rd hour, this isn't going to be completely different, but it's a little bit easier, a little bit different than what we saw in class. So first step, I need to factor the denominator here. So I'm just going to rewrite everything. I'm going to kind of space it out because I'm going to need some space. So there's that first one, minus 2x plus 1 equals, so the top cannot be simplified. It's a square plus a number, and 20 is not even a square. The bottom, though, I know it looks a little bit different, but it is a square minus a square. So the square root of 4, x squared, is 2x. So I can do 2x plus 1, 2x minus 1. So I just square rooted both parts, and then I have one positive, one negative. So now I am going to multiply all 3 parts by the common denominator. Multiply all parts by the common denominator. So this one I'm going to multiply by 2x plus 1, 2x minus 1. This one I'm going to multiply by 2x plus 1 and 2x minus 1. I'm just trying to squish it all together there. And the one on the end I'm going to multiply by 2x plus 1, 2x minus 1. So now to simplify, and I only did it on the top. I did not multiply by anything on the bottom. So think of this as being part of the fraction now. And this one I know is a little scrunched. So this first fraction, what simplifies? Well, I have a 2x minus 1 and a 2x minus 1. So those are gone, and I'm left with x times 2x plus 1. No fraction anymore. The next one, I have 2x plus 1 and 2x plus 1. Those cancel. So now I have minus 2, 2x minus 1 equals, and on this side, they both cancel. So I'm only left with what was originally the numerator, x squared plus 20. All right, so now I'm going to distribute and combine like terms. So 2x squared plus x minus 4x plus 2 equals x squared plus 20. I want to get all my like terms to the same side. So minus x squared minus 20. And I'm going to combine these like terms. So x squared minus 3x minus 18 equals 0. What adds to the middle and multiplies to the end? Well, we get x minus 6, x plus 3. Set each one individually equal to 0, and we get x equals 6 and negative 3. We do want to check for extraneous solutions. If I put any of those numbers in there, any of those two numbers in, are my denominators going to equal 0? No. So we're good. These both work as solutions. All right. So especially that last one, if you still have some questions, let me know. I know, especially third hour, we didn't look at this method very much, and I think it makes it a lot easier. All right. Good luck, and let me know if you need anything else.